Hello, my dear students. Hi, I'm Vipin Mishra and I welcome you all on IMS GATE Academy. I hope you all are preparing well for the GATE exam and in the meanwhile, you are enjoying our GATE Booster series as well. So, in this GATE Booster series, in the session of Power System Part 1, we have discussed some fantastic question and you people have enjoyed that session quite a lot. In the continuation, today I will be taking another session on power system, and you know that yesterday we have discussed the topics like compensation techniques, load flow analysis, and some part of insulators, cable and distribution as well. So today I will be starting from this topic again, where I will discuss some questions of cables and distribution, and then I will continue with fault analysis, power system protection and performance parameters of transmission line. These topics are also very important. And as I have told you yesterday, that before actually designing the question, I have done a lot of research. I have gone through the last 15 years papers, and from there I have picked the topics and I have designed the questions from where you can expect a GATE question in the upcoming GATE exam. So these sessions are going to be very important for you if you are really serious for the GATE exam. So let me discuss with the very first question. Hello Sahil, good evening to you all. So yesterday we were discussing insulators, cable and distribution, and we have done the questions of insulator. So cable and distribution was left. So today I will start with a question of cable. So see student, this is a very important topic from cables, from where you can expect this year a question from GATE in the GATE exam. Very good evening Nayan, very good evening. So see this question, this belongs to the topic cables, and let me first read this question for you and then I will leave this question to you. Okay, I will give you some time and I will wait for your answer, and then we will discuss this question together. So what it says is, the capacitance of a 3-core lead sheathed belted cable are measured and found to be as follows. So you know how a 3-core belted cable look like. So this is a 3-core belted cable that we have. Now what has been given to us is, in the first condition it is written between one conductor and other two connected together to sheath is 5.2 microfarad. In the second case, what we are doing is, between 3 core bunched together and the sheath, when the capacitance is measured, it is found to be 7 microfarad. Now what we have to find is the charging current per phase when the cable is connected to an 11 kV 50 Hz 3-phase supply in ampere will be what? That is what we have to calculate. So this is a very popular topic. This is a very popular topic and very interesting question from this topic, cable. So I am giving you 2 minutes and I will be waiting for your answers. Okay, yesterday you people have solved so many questions and I was very surprised to see that. So I am just waiting the same response from your side today as well. Good evening Naru. So here I am giving you 2 minutes and let me see whether you can solve this question or not. And your time starts right now. We have a 3-core belted cable and we are measuring the capacitance in these two conditions. Now after calculating the total phase capacitance, you have to calculate the charging current as well. So let me see whether you can solve this question or not. Okay, and then we will discuss this together. So let me be aside so that you can have a full view of this question. So we have last 40 seconds. Good evening, Jagdish. Good evening. So last 20 seconds are left, guys. Hurry up. 2 minutes are sufficient to solve this question. So what has been given to us is, in the first condition, what do we have? In the first condition, we are measuring the capacitance between one conductor and the other two connected together to sheath. So what do we have? We have connected the other two conductors with the sheath. We have connected the other two conductors with the sheath like this. Two conductors are bunched together. Let me choose other color so that it will be visible. So two conductors are bunched together and they are also connected to sheath like this. What has been given? Between one conductor and other two connected together to the sheath. So other two conductors are connected together and they are connected to the sheath as well. So what will be remaining here? Very good evening, Asutosh. Naru is getting an answer 14 milliampere. So let me see whether this is correct or not. So what do we have in the first condition? In the first condition, what do we have? So when we will connect two conductors together and this combination is connected to the sheath, then what will happen? We will have only this particular sheath capacitance remaining and these two capacitance remaining. So ultimately what do we have? We have capacitance C2 remaining, and then we have capacitance C1 and one more capacitance C1. Like this will be remaining here, isn't it? When we are connecting the conductors together and then to the sheath, I think this particular combination will be the remaining part that we have here, isn't it? So only this particular part will be there, guys. Now from here, let me call the total capacitance to be CB. If I call the total capacitance of this combination to be CB, then what will be the value of CB? The CB value from here will be, it will be 2C1 plus C2, isn't it? And this is given to you that it is what? It is equals to 5.2 microfarad, isn't it? This is what is given to us. Now, this is the first case that we have, isn't it? Now, what has been given in the second case is that between three cores bunched together and the sheath is 7 microfarad. So, we are bunching all three conductors together to the sheath and then we are measuring the capacitance. So, what will happen? In the second case, what we are doing is that in the second case, we are bunching all the conductors together, isn't it? All three conductors are bunched together. So when you will bunch all the conductors together, what will happen? When you will bunch all three conductors together, only these combination will be the remaining part. So what we have like this combination. This will be the equivalent circuit that we will be having, isn't it? Now if I call this combination to be CA, isn't it? The parallel combination to be CA like this, then can you tell me what will be the value of CA? The value of CA will be 3 of C2, and in that case the total value, measured value, are given as 7 microfarad. So this is the equation 1 that we have, this is the equation 2 that we have. So only this particular part is that what you have to decode, okay? C1 plus 2C2, C1 plus 2C2, it will be C2 plus 2C1, isn't it? It will be C2 plus 2C1 and 3C2. Okay, Naru, just correct the first one. The latter one is correct. So from here, guys, we can calculate the value of C2. C2 will be 7 by 3. Okay, C2 will be 7 by 3 or 2.33 microfarad. Now, when you will come here and you will put the value of C2, which is 2.33, then you will get the value of C1. So what will be the value of C1 from here? It will be 1.43 microfarad. So we have measured the values of C1 and C2. Are you getting the same value? Give me an answer. Are you guys getting the same value as well? C1 equals 1.43 and C2 equals 2.33. Is that correct? So this is how, from the given condition, we will measure what will be the value of C1 and what will be the value of C2. Now what we have to do is, you know that what is the value of C phase? C phase is equals to 3C1 plus C2. How we are getting this? See, this is a delta that we have. This is a delta that we have. Now when you convert this delta into a star, what will happen? These capacitance will be 3C1, isn't it? And this is the neutral point. Now see, and this is the phase R. Now between neutral point, phase R, and between C, what do we have? We have this combination, isn't it? We have C2, then this is the phase R, and then we have the capacitance 3C1, isn't it? So what will be the phase? What will be the total phase capacitance measured between the phase R and the neutral? That will be 3C1 plus C2. Okay, I hope you all know this particular thing. So what is the C phase value? This is 3C1 plus C2. So first case एक बार explain कर दीजिए. Very good. See, in the first case, what do we have? Two conductors are bunched together and they are connected to sheath. So we are merging them up. See, we are merging these two conductors. First we have merged these two conductors and then we have merged them to the sheath. Okay. So what happens? These two are connected together and they are connected to sheath. So what will happen? C1 and C2 will be eliminated. So only this particular C1 and C2. These will be the remaining part, and all these are connected in parallel, isn't it? So that is what we have done. We are having C2 only, and C1 are connected in parallel. So this is what we'll get in the first case. Now we have 2C1 and C2 here. So what will be CB? CB will be 2C1 plus C2, isn't it? So this is how we have calculated the equivalent capacitance that we have measured from the diagram practically. Is that clear, Naru, right now? Is that clear? So these are the way how you can get the values of C1 and C2. So we have this value of C1 and C2 right now. We have the values of C1 and C2 right now with us. C1 is having this value and C2 is having this value. After that, we can calculate the C phase. So what will be the value of C phase? C phase will be 3 times C1. Now C1 is 1.43 plus C2 is 2.33. So from here you can get the value of C phase. So what will be the value of C phase, guys? This will be 6.62 microfarad. Okay. All the capacitance here are in microfarad. So this will be the capacitance per phase of the combination. Okay. Capacitance per phase will always be given by this formula. But we require the value of C1 here and the value of C2. In order to measure C1 and C2, we have to do something, and what we are doing here is, in order to measure these, in first combination we are bunching two conductors together and then to the sheath. In the second case, what we are doing, we are bunching all three conductors together and then we are measuring the capacitance. So in these combinations we will get the value of CB and CA, and these values are given to you. From there we will find the value of C1 and C2. So C phase, capacitance per phase, we have already obtained. Now what we have to calculate is the charging current per phase. So what will be the value of charging current per phase? So the charging current per phase, that will be, charging current is always calculated on per phase basis. So that will be the V phase voltage upon the XC, the reactance. Now XC you know is 1 by omega C or 2 pi FC. So that will become V phase into 2 pi F. C is C phase. Now put the values here. V phase is what? 11 kV. and that is the line value. So we have to write the phase value here. Okay, do not forget this root 3 factor, guys. Always take care of this root 3 factor. Unless what will happen, if you forget to remember this root 3 across your gate exam, now what will happen, it will definitely, it is going to scratch your 3-4 marks. Okay, so always take care whenever it is a 3-phase system where you have to take line values, where you have to take phase values. Always take care of this fact. Unless what will happen, you are going to lose 3 to 4 marks just because of this root 3 factor. Okay, now put the values of 2 pi f c phase. 2 into 3.514, f is 50 and c phase is 6.62 into 10 to the power minus 6. So once you will solve it, you will get the answer. So how much is the IC that I am getting is 13.2 amperes. IC that I am having is 13.2 amperes. Now you just check once your answer. Are you getting the same answer? The 13.2 ampere is the value of charging current IC. Just cross check this. Just cross check your solution once again. Earlier you are getting 14 milliampere. Now you are getting 4.2 ampere. My answer is 13.2 ampere. So are you getting the same answer? Sir, I forget to multiply pi. Yes, that is what am I saying. Calculation mistakes. Okay, calculation mistakes. So do not hurry up. Okay, be patient and solve whatever has been given very patiently, so that what will happen, you have done everything correct here, but just by forgetting the pi value you will lose your mark. Okay, yes. So this problem is from cables, and I'm very sure you are going to get the same kind of question back in the GATE 2023 exam once again. Okay, now moving towards the next question. This belongs to the distribution topic. Now just read this problem with me. What has been asked in this question is, it has been said that an electric train taking of constant current of 600 amperes. So there is a train who is taking a current of 600 ampere. 600 amperes. Thank you everyone. On a section of line between two substations 8 kilometer apart. So a train is moving between two stations which are 8 kilometer apart from each other. Okay, and the train is taking 600 amperes from the line over the track. Okay, maintained at 575 volt and 590 volt. So one station is maintained at 575 volt of voltage and the other is maintained at 590 volt respectively. Okay, the track resistance is 0.04 ohms per kilometer from both goes and returns. So the track resistance is 0.04 ohms per kilometer. Okay, this is the track resistance that we have. The point of minimum potential along the track is at a distance from 575 volt substation will be what? So what we have to find is, from the station of 575 volt, what will be the minimum potential point? So if we want to find minimum potential point, where you have done these kind of things in the chapter, in the topic distribution. Okay, so how this problem can be related to the distribution topic, in which there was a case line fed from both ends. So let's see how I am going to simulate this problem with that topic. Okay, so what has been given to us is, we have two stations. Let me call this station A and this is station B. So these stations are 8 kilometer apart from each other. Now let me take a point P where our train is right now and it is taking 600 amperes of current. Now this station is maintained at 575 volt and this station is maintained at 590 volt, isn't it? This station is maintained at 575 volt and this station is maintained at 590 volt. Now what you have to find, at what distance when the train is taking 600 ampere, at what distance there will be a minimum potential point. Very good evening, Sashi. At what distance from 575 volt station there will be a minimum potential point? That is what you have to find out here. Okay, so let me take this point is at the distance x kilometer from here. Okay, so what is the total length of the line? The total length of the line is 8 kilometer, isn't it? The total length of the line is 8 kilometer. And what is the resistance? 0.04 ohms per kilometer. So what will be the resistance of the section AP? That will be 0.04 into x. The length of section AP is x kilometer. What will be the resistance of the section BP? That will be 0.04. If this is x, then definitely this will be 8 minus x. So the resistance of BP section will be resistance per unit length multiplied by the length. Okay, so this will be the resistance of these particular sections. Okay, now let me take that this current is I of A. Then what will be the current here? So the current here will be IA minus 600, or in this direction we can write it 600 minus IA, whatever way you like it. So guys, did you understand what has been asked in this question? We have to find if the train is taking 600 amperes of current, at what point there will be a minimum potential point. This is what we have to find out here. So did you get the fact how we have simulated this problem with the topic distribution? Give me a reply, guys. Did you find how we have simulated this problem with the topic distribution? Isn't it a very good problem? A very interesting one, isn't it? Very good. Now tell me, what will be the VP voltage? The voltage at point VP, P, that is VP. What will be that voltage? That voltage will be 575 minus the drop in this particular section, isn't it? The drop in this particular section. So the drop in this particular section will be current multiplied by the resistance of this section, and the resistance of this section is 0.04 x, isn't it? This is the resistance of this particular section that we have. Yes or no? Similarly, you can also find this value of VP from this end as well. From this end, this will be 590, the voltage minus the drop in this section, and the drop in this section will be what? 600 minus IA into 0.048 minus x, isn't it? So that will be the drop. That is how you can find the voltage VP from this end and from this end, isn't it, guys? The resistance go and return का है तो 16 किलोमीटर होगा ना? No, Sahil, you are not getting this fact. It has been written here that the track resistance is 0.04 ohms per kilometer, both goes and returns. So whether you are going that side or you are coming from that side, it remains 0.04 kilometer. Okay, ohms per kilometer. So this is how we will find out the voltage VP here. Now what we have to do, from this equation you can get the value of IA here. On solving this equation you can get the value of IA. So what we have obtained as the value of IA is, IA will be 177 minus 24x divided by 0.32. So that will be the value of IA. So from this equation you can find out what will be the value of IA. Okay, after finding the value of IA, what you can do is you can find the value of voltage VP just by putting the value of IA in any one of them. So let me put the value of IA here in this equation. So that will be 177 minus 24x divided by 0.32, that is the value of IA, into 0.04x. So now I have this particular equation. Okay, after further solving this equation I can reduce this up to VP will be 575 minus, I have done all the calculation so that we can discuss more number of questions. Okay, 22.01x plus 3x square, that is the value of VP that we will obtain here. Now if VP has to be minimum, so guys tell me, in order to find something whether it is minimum, for something whether it is minimum or maximum, what we do, if suppose this VP has to be minimum or maximum, what is the way of doing that? You have to differentiate it with respect to the variable, and you have to equate it to 0, and you will get that particular point whether where a maximum or a minimum is actually taking place, isn't it? So what you will do, you have obtained the equation of VP. Now we will differentiate it with respect to x and equate it to 0. Then we will get the value of x where this VP will be minimum or maximum. Okay, so in our case it is minimum. So once you will differentiate it, what you will get? You will get minus 22.01 plus 6x. This is equals to 0, or the value of x will be 22.01 divided by x, or it will be 3.67 kilometer. So this is how you will get, yes, very good Naru, this is how we will get the value of x. So this is a very good problem. Indirectly the topic distribution has been asked here, isn't it? Indirectly, there is no mention of this topic distribution, but you can see here this topic is hidden in particular question. Yes or no guys? So did you like this question? Did you like this question? Very good problem, very good. So this indeed is a very good question. You can expect such a question in your upcoming exam, and that is the purpose of choosing this particular problem here. Okay guys, now so is there any problem? Everything is clear here? I hope so. Yes, very good. Now moving towards the next problem. So this is all about the topic insulator, cable and distribution. Now we are moving towards the very important topic of subject power system, which is none other than the fault analysis. This is a very important topic. From this particular topic, surely you can expect a 2 marks question. Okay, what are the important topics from where generally the questions have been asked? These are symmetrical fault analysis, unsymmetrical fault analysis and bus impedance matrix. Okay, so bus, let's see how what type of problem are generally asked from this particular topic. So here I am having the very first case for you. Let me read the problem first for you, and I'm hoping that you can solve this problem by your own guys. So what has been asked in this question is, a generator with zero resistance having 1 per unit voltage behind transient reactance is subjected to different types of faults. The type of faults and resulting fault current is mentioned in the following table. So when there is a 3-phase fault, the fault current is 3.33 per unit. This is the 3-phase fault current. When there is a line to line fault, the fault current that we have for line to line is this much. And when there is a line to ground fault, then the fault current for line to ground is 3.01. Now what you have to do, you have to find out what will be the value of positive sequence, negative sequence and zero sequence reactance, and the options are given below. So guys, this problem I'm very sure that you people can solve this problem. So I'm giving you 2 minutes, and here your time starts. So take your time and do not make any mistake, and I want the correct answer from your side. So let me see who can solve this problem. So Naru has solved it and he's saying that option A is correct. Absolutely correct. Option A is correct. Now let me see who else is getting the same answer. Very well done, Naru. Option A is the correct answer. Sahil, Asutosh. And everybody else, I'm waiting for your answer as well. Sahil is also getting option A. Very good. Very good. Last 15 seconds. And the time is up. So we are given with these currents, okay? So when there is a three-phase fault occurring, the fault current is per unit is having a value of 3.33 per unit. And how do we calculate this current? The formula of calculation of this current is E upon X1, isn't it? Very good. Very good. So from here, guys, you can get the value of X1. So what will be the value of X1? The value of X1 will be E value we can take 1. The pre-fault voltage is given us and it is equal to 1. So from here you will get the value of X1 to be 0.3 per unit, isn't it? This will be 0.3 per unit. Now, the next thing that we have is the line to line fault. When it is taking the value coming is 2.23 and we know how to calculate this fault. This is equals to root 3E upon X1 plus X2, isn't it? So what will be the value of X1 plus X2 from here? X1 plus X2 from here, it will be root 3E value we can take 1 divided by 2.23. So from here you will get 0.77. So X1 plus X2 is 7.77. So what will be the value of X2 here? The value of X2 here will be 0.77 minus X1, which is 0.3. So it will be 0.47 per unit. Now the next thing is the line to ground fault. So when the line to ground fault is taking place, you know what is the formula of calculation of this? This is 3E upon Z1 plus Z2 plus Z0. And this is given to us, which is 3.01. So from here, what will be the value of Z1 plus Z2 plus Z0, or we can write it X1 because we are given in terms of reactance only. So we can write it X1 plus X2 plus X0. So what will be the value of X1 plus X2 plus X0 from here? This will be 3 into value of E is 1 upon 3.01. So from here you can find out the value of X0 and that is coming out to be 0.22 per unit. So this is how you can solve this question. The purpose of this question is to make you aware of the formulas of the fault that we have in each fault case, isn't it? The purpose of this particular problem is to make you aware of the formulas of the each case of fault, isn't it, guys? So you have to remember these formulas and you can solve this problem. So this is a kind of comparative problem, comparison of fault type of problem. So you can expect this kind of question in the exam as well. So I can see both Naru and Sahil have answered the question correctly. Very good. Now, if you can answer this question, you are in a great touch of this subject. What has been said in this problem is, let me just read this problem. The 6600 volt 10 MVA 3-phase alternators are connected to a common set of bus. Each has a reactance to a positive sequence current of 15%. The reactance to negative and zero sequence currents are 75% and 30% of the positive sequence value. An earth fault occurs on one bus bar if only one of the alternator neutral is solidly earth and the others are isolated, then the magnitude of fault current will be what? That is what we have to calculate. Guys, there are three alternators. Okay, there are three alternators. This fact is missed here. There are three such alternators connected in parallel. And now I am giving you 3 minutes to solve this problem. Okay, if you can solve this problem, you are in extremely great touch of this subject, and your time starts right now. So let me see whether you can solve this question or not. Three alternators are there and they are connected in parallel. One hint I can give you, there is a line to ground fault occurring here, isn't it, guys? See, an earth fault occurs on one bus bar, so it is a line to ground fault. So in case of line to ground fault, all the sequence networks are connected in series. The positive, negative and zero sequence networks are connected in series for one alternator. And if we have three such alternators which are connected in parallel with each other, then what will happen? We will connect all the three sequence network of all the three alternators in parallel with each other. This is the fact you have to remember, and you can solve this problem very easily. Okay. There are three alternators which are connected in parallel. Okay. And what has been given, that only one of them is solidly earthed. So grounding is present in only one of them. Okay. This is G1, this is G2 and this is G3. This much of hint is enough to solve this question, guys. Last 25 seconds are remaining. Naru is getting an answer D. No, Naru, D is not a correct answer. D is not a correct answer. Sahil is getting A. A is also not a correct answer. Okay, so this indeed is a very good problem. So let me just solve this. So guys, first of all, just decode this fact. What has been given here is each has a reactance to a positive sequence current of 15%. For positive sequence current, the reactance is 15%. Okay, so do you know what has been given here? Before that, let me find the base current first. So how do we find the base current? SB upon root 3 into VL. So what is S here? S is basically 10 MVA and B is 6600. So 10 MVA means 10 into 10 to the power 6 upon root 3 into 6600 volts. So first of all, solve this and get the value of I. So what value of I you are getting? We will get a value of I equals to 874.79 ampere. Okay, so that is the base current that we have right now with us. Now what has been given here is, just decode this line. Each line has a reactance to positive sequence current of 15%. So let the reactance to positive sequence current is, let the reactance to positive sequence current to be x1, then what has been given to us is x1 in ohms upon x1 base, this is equals to x1 per unit, and it has been given 15%. So what it will become? It will become 0.15 per unit. Now we have to find out what will be the value of x base. So how do we find the value of x base? In order to calculate x base, we will do V base upon I base. Now I base we already have, V base we can calculate 6600 is the line voltage. So 6600 divided by root 3 divided by I base, which is 874.79, and from here we will get the value of x base, which is 4.35 ohms here. So just put the value here. So x1 value in ohm divided by x base is 4.35. This is equals to 0.15. So from here you will get the positive sequence reactance, which is 0.15 into 4.35. Okay, this is the small thing that you have to do here in order to get the value of x1. So now we have obtained the value of x1. So positive sequence reactance value we have obtained. So we have to just decode this particular line, and from there we can get the value of x1. So once you have calculated the value of x1, did you get the fact how we have calculated the value of x1? Everybody is clear? Everything is clear here? Now see what has been given to us. After that, in the second line we have the reactance to negative and zero sequence currents are 75% and 30% of the positive sequence value. So we have calculated the positive sequence reactance. We have calculated the positive sequence reactance here. We have calculated the positive sequence reactance here. सर VB लाइन में आएगा ना, तो यहाँ पर लाइन में ही तो लिया है ना, यहाँ पर आप निकाल रहे हो XB, ये क्या होता है ओम्स पर फेज में, तो यहाँ पर क्या लोगे? फेज वैल्यू लोगे ना. So this is absolutely correct साहिल. ओके, यहाँ पर लाइन में लिया है. दिस फॉर्मूला इज एस इक्वल्स टू √3 VL/IL. और यहाँ क्या करोगे? रिएक्टेंस करंट दे आर ऑलवेज कैलकुलेटेड इन एम्पियर पर फेज, ओम्स पर फेज. सो देयर यू विल टेक द फेज वैल्यू. इज दैट क्लियर साहिल? नाउ x1 we have calculated. Now what will be the value of x2? x2 is 75% of x1. That means 0.75 of x1. x1 is 0.65. So how much will that become? This will become 0.49 ohms. Okay, Sahil, is that clear? Give me an answer. x0 is only 30% of x1. So it will become 0.30 of 0.65. So this will become how much? 0.19. Okay. Very good. So this is how we will calculate the value of x1, x2 and x0. So guys, now we have the value of x1. Let me write this. x1 value we have with us. x1 is 0.65 ohm. x2 value we have with us, which is how much? x2 value is 0.49 and x0 value is 0.19 ohm. Okay. फिर सर हमें IB भी, अरे मेरे भाई एक बार में स्टार कनेक्शन लोगे या एक बार में डेल्टा कनेक्शन लोगे ना. अगर स्टार कनेक्शन मानते हो तो वहां पर क्या होता है, लाइन एंड फेज वोल्टेज अलग अलग होते हैं. अगर करंट की बात करोगे तो लाइन और फेज करंट तो एक ही होती है. डेल्टा मानते हो तो डेल्टा में क्या करते हो? डेल्टा में लाइन और फेज करंट अलग अलग होती है, पर लाइन और फेज वोल्टेज तो सेम होते हैं ना. सो वेदर इट इज स्टार और वेदर इट इज डेल्टा, one quantity will have the same line and phase value and other quantity will have different line and phase value. Isn't it, Sahil? Isn't it? So here we are taking different line and phase concept for voltage. So for current it will be same, isn't it? Are you getting this fact? Yes. So voltage हम लोगों ने phase किस में लिया है? phase में. So the current is always in phase value. इधर current किस में है? phase में ही है. Okay. So now guys, we have x1, x2 and x0 with us. Now Three alternators we have, these are connected in parallel. So for one alternator, what will be the equivalent diagram? So for one alternator, the equivalent diagram is like this. See, the equivalent diagram is like this. Yes or no? I hope you guys will agree with me that this is the equivalent diagram for one alternator for line to ground fault. Yes or no, guys? If LG fault is there, the sequence reactance diagram is like this or not? Do you agree with me? Do you agree with me? If there is an LG fault, we will connect all the sequence network. This is what? This is the positive sequence network that we have. This is the positive sequence network we have. This current is IA1. This is the negative sequence network that we have. This current is how much? This current will be here at IA0. And this is the zero sequence network, and this current here will be what? This current will be IA0. Do you guys agree with me? When there is an LG fault, all the sequence networks are connected in series. Yes or no? Now in our case, we have three alternators connected in parallel. So the individual positive sequence, negative sequence network will be connected in parallel with us, each other. Yes or no, guys? So what we will do here? What we will do here? See, what will happen? This is for first network, okay? This is for first generator. Now for second, what will happen? We will connect similar such network in parallel with it. For third network, we will connect similar such network in parallel with it. Yes or no? This is X1, this is X1. Now this is for generator 1, this is for generator 2, this is for generator 3. For negative sequence as well, we will connect all the three sequence network, respective networks in parallel with each other, X2 and X2. This is for generator 1, this is for generator 2, this is for generator 3. Now here comes the turn for zero sequence current. So if you see, for zero sequence current, let me take that generator 1. It is connected, it is having the grounding. See what has been written here. If only one of the alternator neutral is solidly grounded and others are isolated, so only one generator is having the neutral grounded. So which generator is having the neutral grounded, only that will have the zero sequence reactance, only that will have the zero sequence current flowing, and others will not have the zero sequence current. So other will be having an open circuited zero sequence impedance network. Yes or no, guys? So see here, what we have done, we have open circuited the networks for, this is for G1, this is for G2, and this is for G3. Did you guys get this fact? Just tell me. The generator which has neutral grounding, that generator will have the positive sequence current, the zero sequence current flowing across it. The generator which does not have the neutral grounded, there will not be a zero sequence current flowing, isn't it? So for this, generator 1 is having neutral grounded. So for that, we have connected its network and the zero sequence current will be flowing in this network. But these two will be open circuited because the neutral is not grounded. So there will not be any zero sequence current if the grounding is not present. If there is no contact with the earth, no zero sequence current will be there. So for that reason, G2 and G3 will be open circuited. Did you guys get this fact? For positive and negative sequence network, no such concept is there. So we have not considered any such thing here only, isn't it, guys? So now can you tell me, positive sequence network, three equivalent X1 are connected together in parallel, three X2 are connected in parallel here, and here only we have X1, X0. So can you tell me what will be the X1 equivalent here? X1 equivalent will be X1 by 3, isn't it? Three equivalent impedances are connected in parallel. What will be the equivalent impedance? It will be 1 by 3 of any one of them, isn't it? So X1 is how much? 0.65 divided by 3. So you will get the value of X1 here. and that will be 0.21, and all these values are in ohms. Similarly, what will be x2 equivalent? That will be x2 by 3 or 0.49 by 3, or what you will get? You will get 0.16 ohms. Okay, but when it comes to x naught equivalent, this is only this x naught, guys. So what is the value of x naught? It is 0.19 ohm. Now tell me, did you get this fact? Did you get this fact? This is a very important thing that I just want you to understand here. Did you get this fact? Yes, total will be 0.59. Now what we have to do? We have to find out the fault current. This problem is yet not done. We have to find out the fault current. And what is the fault current? Fault current is 3E upon x1 plus x2 plus x0. Now normally we take the value of E to be equal to 1. When all the things are in per unit, it has been written always for E that you can take it 1 per unit, but things are in ohms here. So what will be the value of E? What is E? E is the pre-fault voltage, and pre-fault voltage is how much? The voltage of the system in phase value, because we are calculating current. Okay, what is the value of x1 plus x2 plus x0? 0.21 plus 0.16 plus 0.19. So once you will solve it, you will get 19.8 kilo ampere. 19.8 kilo ampere will be the answer here. Okay, so do we have any option here? 19.8 kilo ampere means 19818 ampere. So this is the very closest answer. So answer B is correct. Okay, neither A nor D is correct. Answer B is correct here. So this problem has a lot of twists and turns, and that is the purpose of choosing such kind of problem here, guys. There are so many concepts involved in this one problem, and if you have very well understood all these concepts, I am very sure there might be a question belonging to any of the concept and you will be able to solve that. Yes, it is a hard problem, but it has so many concepts involved. What will you do if you have alternators connected in parallel? Their sequence network will be connected in parallel. This is the first thing that you have learned here. If one of the generator is having its neutral not grounded, that zero sequence network will not be connected to that. That is the second thing that we have learned here. And the third important thing that we have learned here is, if x1, x2 or x0 are not in ohm, then E will be not, E will not be equal to 1. It will be equal to the system voltage. Okay, third thing that you have got here. After that, what we have learned here is how to find the value of x1, x2 and x0 if such a condition is given. Okay, if such a condition is given, how to find the value of x1, x2 and x0, and this is how to do these things. Okay guys, so it is a multi-concept type of question which involves a lot of concepts. Okay, so did you guys like this problem? Have you seen this kind of problem before as well? And that is the purpose of choosing this problem. Okay, through this concept I have made you learn a lot of things here. Okay, which will be very, very useful for you in the upcoming GATE exam. Is that clear? Never seen, sir. Wow. That is the purpose of this GATE Score Booster series, guys. And I'm very sure that GATE Score Booster series is really serving its purpose. Okay. So now it's time to move to the next question, because today we have a lot of questions. So do not waste the time here. Now see this question. I'm very sure you can solve this question. It has been said here that a 3-phase 20 MVA 10 kV alternator has internal reactance of 5% and negligible resistance. So these are the ratings of the generator, and right now it is having 5% of internal reactance. Okay. The external reactance per phase to be connected in series with the alternator. Now we are connecting an series reactance along with the older reactance, so that what will happen, the steady state current on the short circuit does not exceed 5 times the full load current will be what? We have to find out how much reactance we should add in series so that this condition will be satisfied. Okay, I hope you have understood the problem. Now I am giving you 2 minutes and I am very sure that you can solve this problem by your own. So I am getting answers from Sahil and Naru. What about others? Are you people not able to understand these questions, or you are really finding these questions to be a very difficult one? And I must appreciate Sahil and Naru because you people are answering all the questions and you are reaching up to the mark. So you are in a great touch of this subject. Your preparation is very good. I must appreciate this fact. Well done Sahil, well done Naru. Now let me see who can solve this problem. The answer that we have to calculate is in ohms. Okay, do not forget this fact. Thank you Ankit. Thank you so much. But I think you should concentrate on the problem as well, okay? Last 10 seconds. Fully focused. Very good. So guys, what has been given to us is, earlier the generator has an internal reactance of 5%. Now when we are inserting a series reactance, what happens? At that time, the steady state current on short circuit does not exceed 5 times the full load current. Okay. So what has been given to us is the ratio of full load current, to the short circuit current. The ratio of full load current to the short circuit current. That is how much? That is 1 by 5. Okay. 1 by 5 means this is 20%. This is happening when you have inserted the reactance. Okay. After inserting reactance. So what will be this? Full load current upon short circuit current. What will be this, guys? This will be the total reactance required, isn't it? So according to this requirement that we have, this is the value of total reactance required. The total reactance must be such. Total reactance required. The total reactance must be having such a value so that this ratio must be maintained, isn't it? So this is the requirement that we want. Okay. Now what has been given? Internal resistance is what? How much is the internal resistance right now? Reactance right now? Internal reactance given to us is 5%. So now the question arises, how much reactance we should add? So how much reactance is added? How much reactance we are adding here? So the reactance added must be, guys, 20 minus 5%, that is 15%. So this is the value of reactance that we are actually inserting to maintain such a condition here, isn't it? Earlier we have 5% reactance. Now we are inserting some reactance to maintain this particular condition. So how much reactance we have added? That is 15%. Now what students normally does, they will write answer here that it is 0.5. per unit, isn't it? That is wrong, guys. You have to answer in ohms. You have to answer in ohms. So this is what the reactance added. Let me call this X dash, and this is 0.5 per unit or 15%. So how do we calculate? How do we convert here this percentage value into the ohms value? That is what we have to see here. So how do we calculate the percentage reactance, guys? So percentage reactance, if you want to calculate it, you will calculate it by X value in ohms divided by X base into 100. This is the way you can calculate the percentage reactance. Now, X ohm is what you have to calculate. X base you can extract from here, from the given data. So what will be the value of I base? I base, again we can find out the same way we did in the last case, S base upon root 3 into VL. So what is S base here? 20 MVA. 20 into 10 to the power 6 divided by root 3 into what is the value of VL here? 10 kV. 10 into 10 to the power 3. So I base that you will get from here is 1154.7 amperes. That is the value of I base that you will get here. Okay. Now what will be the value of X base? Now what will be the value of X base? X base will be V base upon I base. V base will be what? V base will be 10 kV. So 10 into 10 to the power 3 divided by root 3. That will be the value of V base, and we have the value of I base with us, which is 1154.7. So from here you will get the value of X base to be 5 ohm. Now come again here. Percentage reactance we have 15. X ohm value we have to calculate, and X base is 5 into 100. So from here, what will be the value of X ohm, guys? That will be 0.75 ohm, and that will be your answer. As simple as that. So I think you must practice this particular thing as much as you can, because you can see this is the second time we have done the similar kind of calculation, isn't it? So tell me, guys, whether this problem is clear to you all. Did you get the concept required to solve these kind of questions? Just go with the flow of the question and you will get an idea what actually we have to do here. Very good evening, Nikhil. Okay, just go with the flow of the question, and while going through the flow of the question, you will get an idea what is required to be done here. Okay, and these are the very general concept, isn't it? Percentage reactance, per unit value, how to calculate this thing. This is simple phenomena. Ohms value upon the base value, that will give you percentage value or the per unit value. Now how to find out X base? X base is basically what? X base is V base upon I base. Both currents and reactance or impedance, they are always calculated on per phase basis. Remember, my friend. Okay, so I base we have calculated here, and V base already given to us, converted into phase value, and you will get the value of X base. Now come here and put the values, you will get your answer, isn't it? Isn't it, guys? So are you getting the same answer as well? And whether this particular concept is clear to you? This question belongs to symmetrical fault current, okay, and symmetrical fault current. From the last few years, we are getting questions from unsymmetrical fault. So be ready for this year. You may get such kind of question in the upcoming GATE exam from the topic symmetrical fault analysis. So be ready for such kind of question, okay. Now moving towards the next question. Now see this particular question. This belongs to the bus impedance matrix involving the fault calculations as well. So what has been given in this particular question is the Z-bus matrix of 2-bus power system is given to you. The Z-bus matrix we are having, now we assuming all pre-fault voltages to be 1. All the pre-fault voltages, whether for bus 1 or whether for bus 2, they are given 1 per unit. Now what we have to do is, if a solid 3-phase fault has taken place at bus number 1. So fault is happening at bus number 1. Remember this fact, okay? Fault is happening at bus number 1. Then the post fault voltage at bus 2 will be what? Okay? What we have to calculate is what will be the post fault voltage at bus 2. So post fault voltage at bus 2, that will be the pre-fault voltage at bus 2, minus the fault current into the impedance between bus 1 and 2. This is the formula required to solve this particular problem. If suppose the fault is happening at bus number 1, and if you are about to calculate V1, then V1 must be here, and rest the things remain same, isn't it? Now V2 is how much? V2 is 1, but we don't have the value of fault current. And what is the value of Z12? So fault current we don't have, and the value of Z12 is J.1. Now we have to find out what will be the value of fault current. So fault current will be, guys, the value of fault current will be the see, fault is happening where? The fault is happening at bus number 1. So what is the bus number 1 voltage? So V1 voltage upon, since the fault is happening at bus number 1, so from this Z matrix you will use the impedance Z11, impedance of the bus, impedance involving bus 1 only. Okay, so this is how we will calculate. If suppose the fault was happening at bus number 2, what you will do? You will put V2 upon Z22 here. Okay, so only diagonal elements are used to calculate the fault current. This fact you have to remember. Okay, so since the fault is happening at bus number 1, so bus what diagonal impedance will be involved? Z11. If the fault will be happening at bus number 2, you will put Z22 here. Okay, V2 upon Z22. So V1 is 1 here, and what is Z11? Z11 is minus J.4. So what you will get here? You will get minus J.5, isn't it? Minus J.5 or plus J.5? No, minus J.5, minus J2.5 per unit. That will be the fault current. Okay, now come here and put the values. Minus J.25 is the fault current that we have. So minus J2.5 multiplied by, what is Z12? It is J.1. So guys, you have to solve this particular equation only, and what you will get? You will get the value of post fault voltage at bus 2 will be 0.75 per unit. So this is how you can solve this particular question. Naru is saying plus J. Where plus J? 1 by J will be minus J. Yes, and minus is already there, so it will be plus here. Very good. So this will be plus here, and again we will get plus here. Now whether the answer is going to change from here? J and J will be minus J square, and that will be plus. So 1 plus 0.25. Yeah, that will be 1.25. Very good. That will be 1.25. So 1.25 is the correct answer. Is that clear, Naru, right now? 1.25 is the same answer you are getting here. Tell me, guys, are you getting 1.25 as the answer? Very good. Are you getting the same answer? Let me just tell this particular fact. J and J will be minus J square, that minus 1. This will be plus 1, 0.25, 1.25. That will be the answer, isn't it? Yes or no, guys? So did you get this fact? What to do in such a scenario when Z-bus matrix is given to us? So whenever you have Z-bus matrix, if suppose two types of question you may get. Either you may get this kind of question, or you may get a question where you have to calculate the fault current. So if the fault is happening at bus number 1, wherever the fault is happening, only that particular diagonal impedance will be involved. If suppose the fault is happening at bus number 2, what you will do? You would have been divided it by Z22. Okay, if suppose this is a 3-bus system, you would have divided for calculation of fault current, it will be V3 by Z33. So did you get this fact? If suppose this kind of problem will be there in the exam, you will be able to solve it, isn't it, guys? Did you get the concept required to solve this particular case? I hope you have. Now moving towards the next question. Okay, just read this question with me. What has been said in this question is a 50 hertz alternating voltage having a RMS value of 100 volt is applied to a series RL circuit. So this is the voltage applied to this RL circuit and it is having an RMS value of 100 volt. By closing a switch, the resistance is 15 ohm and the inductance is 0.12 Henry. The instantaneous value of voltage that will result in the absence of any DC component of current upon closing the switch will be what? That is what you have to calculate. So this is a case of transient in RL circuit. Okay, this is the case of transient in RL circuit, and at the instant when you have closed the switch, at the instant at t equals to 0, when the switch is closed, let me give you a hint and then I will ask you to calculate. When the switch is closed, the current in this particular type of circuit will be given by Vm by Z sin omega t plus alpha minus theta minus Vm by Z sin alpha minus theta e to the power minus r by L into t. Okay, this is the expression for transient current in RL circuit once the switch is closed at t equals to 0. Now this is the steady state sinusoidal current and this is the DC offset current that we have. This is the DC offset current that we have. Okay, now this much hint is enough to solve this problem. This much of hint is enough to solve this problem, guys. This is the DC offset current that we have. Okay, this is the expression. Now what has been given to us? The value of R is 15 and the value of L is 0.12. So the value of R is 15 ohm and the value of L is 0.12 Henry, isn't it? Yes. And RMS value of voltage, Vrms is 100. So what will be the value of Vm? That will be 100 root 2, isn't it? So that is the value of Vm that we have. Now we have to calculate what? This much of hint is enough. We have to calculate the instantaneous value of voltage that will result in the absence of any DC component. So guys, when this DC component is disappearing, let me just show it to you. So when this DC offset current is disappearing, at that moment what will be the value of instantaneous voltage is what you have to calculate. Okay, so this is the formula required. Now I am giving you 2 minutes to solve this problem and let me see whether you are able to solve this question or not. All these questions are very good and all these questions are very probable questions that you can see in the upcoming GATE exam. After the GATE exam, I will come live again and I will show you that these questions that we have discussed in the class have appeared in the GATE exam. I'm very sure about that, guys, because I have done a lot of research while preparing these questions. Let me check who can solve this question. Last 35 seconds. So this is the formula required. Naru has answered this and he is saying option A is correct. Naru, just verify your answer once again. Just verify your answer once again, because A is not the correct answer here. So guys, from this particular given problem, first of all find the value of Z, because Z is also required here. So Z will be R plus J XL or J 2 pi FL, isn't it? So from here what you will get the value of Z. R is what? R is 15 plus J 2 into 3.14 into 50 into 1.12. So from here you will get 15 plus J 37.7. That will be the value of Z. And what will be the value of theta here? Tan inverse 37.7 divided by 15. So the value of theta that you will get is 68.30. Okay. So from the given value of impedance you can find out what will be the value of theta. Is that clear? This is how you will find out the value of theta. Let me write the value of theta that we have calculated. The theta value is 68.30 here. Okay. Now what I am saying is just go as per the flow of the question, and in the flow of the question you will see one line where it is written that DC offset current is 0. So guys, when DC offset current is getting 0, then you are getting one fact from here, that sin alpha minus theta that will be equals to 0. That means alpha minus theta that will be equals to either 0 or 180. So from here either alpha will be theta or it will be 180 plus theta. So either this will be having a value of 68.30 or it will be having a value of 180 plus 68.30, that is 248.30, isn't it? So these are the two values of alpha that we have. Now what will be the voltage appearing at that instant when this scenario is happening here? That voltage will be what? That voltage will be Vm sin omega t plus alpha. This is the instantaneous voltage that we have here. V equals to Vm sin omega t plus alpha. Now whatever has been done here is done for t equals to 0 value, isn't it? So that will be Vm sin alpha only. Okay guys. So for here what will be the value of Vt that you will calculate? Vm is what? Vm is 100 root 2 sin. First you will take this value of alpha 68.30. Then you will get an answer of plus 131.37 volt. Okay. Then again you will do the same analysis with this particular value of alpha, that is 248.30, and then you will get minus 131.37 volt of answer. So which option is correct here? Option B and option D both are correct. Is that clear? Now tell me, did you get the concept involved here? Did you get how we have solved this question? Tell me guys, did you get how we have solved this question? This is the instantaneous voltage appearing at t equals to 0 when this is happening. DC offset current is getting equal to 0. So we have different values of alpha here. So when you put the value of alpha here, first you will get this answer and then you will get this answer, plus minus 131.37. Now tell me, do you have any doubt here? All you need to do is to remember, you have to remember this particular formula involved here. If you are able to remember this formula, you can solve this question. Sir, I have took alpha equals to 0. Why will you take alpha equals to 0? Sin alpha minus theta, this is equals to 0. So from here alpha minus theta will be equal to 0, isn't it? So you will get alpha equals to theta or 180 plus theta, isn't it? So now your confusion has been removed. Very good. Now let me move towards the next problem. Now this is a very good problem. This is a very, very good problem. Let me see whether you can answer this or not. What has been said in this question is a balanced three-phase load consists of delta connected impedances Z delta, this is delta connected impedance in parallel with solidly grounded star connected. So in parallel with star connection, and star connection is solidly grounded here. Okay. Which of the following represents the zero sequence network of the above load? So I am giving you only 1 minute. 1 minute is sufficient to solve this question. So tell me guys, what you will do to solve this question? A delta and a star network are connected in parallel. Now you have to comment for the zero sequence network, what will be the equivalent diagram? For zero sequence network, what will be the equivalent diagram? For the zero sequence network, what will be the equivalent diagram? This is very simple. Option number C. Option number C is correct. Narus, just think once again for this question. In delta connected, whether zero sequence current flows in the line, and in star connected, when do we have zero sequence current flowing? When there is a ground return. So ground return is there. So in star network, there will be zero sequence current flowing. But do we have zero sequence current here? See, here we have delta connected networks. Okay. So in delta connected networks, zero sequence current is there. Zero sequence current does not flow in delta connected network in the lines, isn't it? And in star, zero sequence current will be there if we have grounding present. So grounding is there and it is a solidly grounded case. So from here, since no zero sequence current is flowing, so no impedance will be offered from here. But here we have zero sequence current flowing. Here there will not be any zero sequence current, isn't it? This is 0. But here we have zero sequence current present, isn't it? Because there is a ground return available. Yes or no? So since there is no zero sequence current, no impedance will be offered, and here we have zero sequence current, so there will be some impedance offered, so only ZF will be there, isn't it? So option B is the correct option. Yes, now you got it right. Very good. Very good. So is it a very good question? Sorry sir, confused ho gaya tha. No problem. You can have problems here right now. Okay, and the purpose of this series is to get you confused. Isn't it? The purpose of this series is to let you aware of all the concepts, all kind of questions that you may see in the GATE exam. So if you are getting confused, if you are not getting your answer, that is absolutely perfect here. Okay, you can make n number of mistakes here, and I am very sure by learning these concepts here, you will do very good in the GATE exam. Okay guys, so is this a very good question that we have? Is this a very good question that we have? Okay, so this is the end of this particular chapter, the fault analysis. Very good. So I think shall we take a break right now? Shall we take a 5-minute break? And then we will meet after the break, and then we will discuss this one of the most important topic as far as the GATE exam is concerned, power system stability, a topic that will definitely give you a question. So I am taking a 5-minute break. We will meet right after the 5 minutes. Okay. Hello student, welcome back. So now we are left with this topic, power system stability. This is also one of the most important topic from where regularly the questions are coming, and you can also expect question in the upcoming GATE exam. What are the different topics from where the questions have been asked are stability limit, swing equation, power angle curve, and the application of equal area criterion. Okay, so let me just start with the first question. So here it is, the first question that I have for you. So let me just read this question for you. A generator having inertia constant H equals to 6 megajoules per MVA is connected to a synchronous motor having inertia constant of H equals to 5 megajoules per MVA through a network of reactance. So in this case, we have a generator, we have an alternator, synchronous machine connected to an alternator load synchronous motor, isn't it? Synchronous machine, synchronous alternator is connected to synchronous load, that is the motor. So this is the case that we have here, and they have whatever is the value of their different inertia constant, this is also given to us. The generator is delivering power of 1 per unit to the motor when a fault occurs which reduces the delivered power. At the time when the reduced power delivered is 0.7 per unit, the angular acceleration of the generator with respect to the motor in electrical degree per second square will be what? That is what we have to calculate. Okay, so I am again giving you 2 minutes because this is a very simple case. I would have to say only a little concept required to solve, only per one point is required. I just want to know whether you know that particular point or not. If you know that particular point, you will be able to solve this question. I am very sure you can solve this question. So you have 2 minutes left. Remember the fact, it is a case when where we have one alternator, means synchronous machine connected to the motor, that is synchronous motor or the synchronous load. So synchronous alternator is connected to synchronous load. So in this case, how do we calculate the equivalent inertia constant? That concept you should know only. Okay, when we have two alternators connected in parallel, this is a very general case. In that case, we simply add the inertia constant. But what will you do for the inertia constant in this particular case? Just a small concept you have to remember, and you will be able to solve this question. Last 40 seconds. Last 10 seconds, guys. Hurry up. So what is the swing equation? In swing equation, we have m d square delta by dt square. This is equals to ps minus p, isn't it? Isn't it, guys? This is the swing equation that we have, or this is what this is, we may write it pa as well, the acceleration power. So from here, what we have to find? We have to find what will be the value of d square del by dt square, that is the angular acceleration, and that will be equals to ps minus pv over m. Okay, now ps is 1 and p is reduced to 0.7, so this is given to us divided by m, that is 0.3 by m. Now if we are able to find the value of m, we can calculate this particular thing very easily. So you know the value of m is what? The value of m is equals to h into s upon pi into F, but we have to calculate in electrical degrees, so we will write instead of pi 180 here. Okay, so that will be H into S upon 180 F. Since all the powers are given in per unit, so you can remove this S because power are expressed in per units. So that is the case when you have divided by S, that values you are getting only then in that case. Okay, so you can remove S from here because all the powers are in per unit here. Now how to find the value of H? Guys, the value of H equivalent here will be H of generator into H of motor divided by H of generator plus H of motor. That is the parallel combination of the two inertia constant. Okay, this we are doing here because we have synchronous alternator connected to synchronous load. If suppose instead of that we have two alternators connected in parallel, then in that case we have simply added them, but this is not the case here. So I just want you to remember this particular fact because this may be a problem in the GATE exam. So we have different values of H. Generator is having an inertia constant of 6 and the motor is having an inertia constant of 5. So 6 into 5 upon 6 plus 5, that is 30 upon 11, or we will get 2.72 megajoule per MVA as equivalent inertia constant. Now we can put the value of M here, or we can directly put the value of M here, isn't it? So what will be the value of d square del by dt square? So d square del by dt square is 0.3 upon M. What is the value of M? M is H equivalent upon 180 into F. So just put the values here. 0.3 into 180 into F is 50 and the value of H equivalent is 2.72. So from here you will get the value of d square del by dt square, and that will be 992.64. okay, 992.64, and it will be in electrical degree per second square because we have taken the value of pi to be 180. Okay, so this is how we will calculate the value of d square del by dt square here. I hope you have understood the concept, isn't it? So this is the formula required to solve this problem. Okay, and you have to remember this fact that M will be H upon 180 upon phi. F S value we can ignore because all the powers are in per unit, and the most important concept here is how to find H equivalent. So in this particular case where the alternator is connected to synchronous load, this is the way we can find the value of H equivalent. So now what is left here? Just put the values and calculate the answer. So this will be the answer here, 992.64 electrical degree per second square. That will be the value of angular acceleration. So this is how we will solve this particular question. Okay, I hope you have liked this question and you are getting the concepts required to solve this question as well. Now after that I have one more problem for you, and let me just read this problem. For the circuit shown below, this is the circuit shown below, in which we have this particular switch through which a shunt capacitor is connected. So the steady state power limit will be what? That is what we have to calculate, and options are 0.4 per unit with switch open, 1.27 per unit with switch S closed, 2.24 per unit with switch S open, and 1.42 per unit with switch S closed. Okay, so a steady state power limit is what we have to calculate. Means we have to calculate the P max value, which is EV upon X. EV upon X. So in case 1, when the switch is open, okay, so for switch open, what will happen? So when we have the switch open, in that case what will happen? When the switch is open, all we need to do is to calculate the equivalent X. So for the switch open condition, equivalent X will be what? Generator reactance, which is 1 per unit. Then we have the transformer reactance, which is 0.2 per unit. Then we have transmission line whose reactance is 0.6. After that we have one more transformer whose reactance is what? 0.2. So just sum them up. and what you will get? You will get X equivalent value to be what? X equivalent value will be what? It will be 2 per unit, isn't it? That will be 2 per unit. So the X equivalent value will be, guys, 2 per unit. No, we have missed this motor reactance, isn't it? That is also we have to add. So it will become 3 per unit, isn't it? This is what we have missed here. So it will become 3 per unit. So X equivalent value we have 3 per unit. So what will be the steady state power limit? E is 1.2 and V is what? 1 divided by 3. So what you will get? 0.4 per unit. That will be the steady state power limit. That will be the steady state power limit that we will be having when the switch is open. So option A is correct. Now what will happen in the second case? What will happen in the second case? In the second case, when we are closing the switch. So guys, when we have closed the switch, what will happen? First of all, we have an alternator whose reactance is given to us. Then we have the transformer, and after that we have a transmission line, and then we have here, as when the switch is closed, a capacitance is connected whose reactance is minus J1. Then we have a transformer and the motor. Okay, so this is the case that we have after that, and the motor is having a voltage of 1 per unit. Okay, this is the case that we have. This is X of G, this is X of T1, this is X of L, this is X of T2, and this is X of M, which is 1 per unit. What is XT2? XT2 and XT1 both have the value of 0.2 per unit. So this is J 0.2, this is simply J, and XL, this is J 0.6, and what is this? This is J 0.2, and XG also has a value of, I think, 1 per unit. So this is also J1 per unit. So this is the diagram that we are having right now. Okay, so we can reduce this diagram up to the instant where we only have a generator and this equivalent reactance. To the left of this capacitor will be what? To the left of capacitor we will be having 1.8. So J 1.8 is there, and then we have a capacitor of value how much? Minus of J1, and let me remove this bus sign here. After that what we have? After that we have the motor, and this reactance is having a value of J 1.2 per unit. Okay, so now we have this case where E is what? E is 1.2, and what is V? V is basically 1 per unit. So now guys, can you tell me what to do after that to calculate P max? For P max we require the equivalent value of X equivalent. So if you see, this is what? This is a star network that we have. Okay, this is a star network that we have. If we are able to convert this star network into the delta network, we will get the value. So if we convert this star into delta, what we will get? Generator voltage will be there, and when we will convert this star into delta, this kind of network we will be getting. This kind of network we will be getting here. This is V, which is 1 per unit. This is E, which is 1.2 per unit. Now what will be the value of this reactance? So when you will convert this star into delta, the value of this reactance, which is, let me call this X equivalent, that will be J 1.8 plus J 1.2 plus J 1.8 into J 1.2 divided by minus of J1. So you will get J 8.84 here. So that value will be J 0.84. So now guys, we are having this voltage which is E, which is 1.2. We are having this voltage which is V, which is 1 per unit. So what will be the value of P max right now? P max value will be E upon X equivalent, or 1.2 into 1 upon 0.84. So how much we will get? We will get 1.42 per unit as answer. Okay, we will get 1.42 per unit as answer. So do we have any answer which is having the values? Yes, option D is having the value. So this is how we will solve this problem. Okay. So are you getting this particular questions? What has been asked in it? The first case is very simple. When the switch is open, it is very easy to find the X equivalent and we can calculate P max here. But when the switch is closed, you will get this kind of network. But in order to get P max, we require this kind of network. So we have to convert this star into delta. For that, we require the network, the impedance connected between these two. So this is, by doing this simple calculation, you can do this. Okay. And ultimately, then we will find the answer. Okay. Got it, sir. Very good. So this is also a very good question that we have. Now, coming towards this question. Let me just read this question for you. A 50-watt generator connected directly to an infinite bus operating at a voltage of 1 per unit has a synchronous reactance of 1.2 per unit. This is the rating of generator that we have. The generator no load voltage is 1.3 per unit and its inertia constant H is 4 megajoule per MVA. The generator suddenly loaded to 70% of its maximum power limit. The frequency of resulting natural oscillation of the generator rotor will be what? The frequency of natural oscillation is required. So let me write the formula and then I will give you time. Let me give you a hint. Frequency of natural oscillations. This has never been asked in GATE. This time this can be asked. Okay. Frequency of natural oscillation, because this much of thing is left to be asked from this particular topic, and that is why I have chosen this question. This is equals to d bar P upon d del at del naught divided by M. So this is the required formula to solve this question. Now I am giving you time. So I am giving you 2 minutes and I will wait for you and let me check whether you can solve this problem or not. So this is the formula required to get the natural frequency of oscillation. Now it's over to you. You have 2 minutes to solve this question. You have to find the value of M and you have to find the value of dP upon d del at del equals to del naught. These two things you have to calculate, then you can calculate the frequency of oscillation very easily. So last 30 seconds we have. So guys, if you just read this particular line, what has been written here is the generator is suddenly loaded to 70% of its maximum power limit. This is the hint. Okay, from here what you can calculate is what is the electrical power output. This is given by P max sine del naught. And the generator is loaded to 70% of its maximum. So this is exactly equal to what? 0.7 of P max. This is what is given to you. So from here you can find the value of del naught. which will be sine inverse 0.7. Okay, so what you will get? You will get 44.42 degree, the value of del naught. So this is the hint from where you can get the value of del naught. Now what is required? You have to calculate dp upon d del at the angle del naught. So once you will differentiate it, what you will get? So once you will differentiate it, guys, you will get p max cos del naught at del naught. Now what will be the value of p max? This is you can calculate by EV upon x cos del naught at del naught. Now do we have the value of E and V? Of course we have. The value of E is 1, the value of x is 1.2 and the value of V is 1.3. So 1.3 and 1.2. 1 into 1.3 upon 1.2 cos of what is del naught? 44.42. So from here you will get the value of this factor. So how much it will be? This will be equals to 0.7737 per unit upon radian. Okay, per unit upon radian. Deber P upon Deber del. Power is in per unit because all these values of EV and X are in per unit, and del is in radian. So what will be the unit? Per unit upon radian. सर ड्रूप कैरेक्टरिस्टिक का भी क्वेश्चन करा दें. रुपेश, just go to the last video, the last session that I have taken yesterday. There we have solved almost 3 to 4 questions from Doob characteristic. Okay, just go there and just see that video and you will get the overview of that topic as well. I have taken that topic from very scratch level. So if you don't know the concept, even then you will be able to get these things. Okay, so just go to the playlist and see the video of last session that I have taken on yesterday. Is that clear, Rupesh? So there you will find the questions related to that topic. So coming back to the question, Deber P upon Deber del at del naught, that we have calculated. Now it's time for M. So how do we calculate the value of M, guys? The M, if you want to calculate the value of M, what is the formula required? The formula required to calculate the value of M is equals to H into S upon pi into F, isn't it? H into S upon pi into F. Since this is in radian, so we can use pi. Sir, power system का formula session भी आएगा? Yes. We have planned for that and very soon we will announce that. Okay, very soon we will announce that. Within 2-3 days we will announce that. In the upcoming month of January, we are going to have this particular session. Okay, Rupesh? Okay, Rupesh? So I will wait for you in those sessions as well. Okay? Yes. So M is equals to HS upon pi F. Since powers we are taking in per unit, so we can remove S from here. We can only write pi into F. Now what is the value of H? The H value is given to us 4 and frequency is 50. So 4 upon 3.14 into 50. So what will be the value of M, guys? What will be the value of M? The value of M will be 0.0212. Okay, 0.0212 per unit second square per radian. Okay, so we have calculated everything. Now what will be the frequency of oscillation? So frequency of oscillation, that will be under root of, what is the required formula? The required formula is Deber P upon Deber del, Deber P upon d del at del naught divided by M. So just put the values and you have obtained the answer. This is 0.7737 and how much is this? This is 0.02, sorry, 0.02. Okay, let me write this once again. This is 0.0212. 0.0212. So just put here and you will get 0.96 and you will get 60.4 radian per second. Okay, so the frequency of oscillation that we have calculated is m 0.025 आ रहा है, not a great difference. Okay, सर मैंने आपका पावर इलेक्ट्रॉनिक्स का सेशन देखा, बहुत हेल्प मिला मुझे, थैंक यू सर, थैंक यू रुपेश, थैंक यू सर। EMFT का सेशन अभी तक नहीं आया है, ओके ओके ओके, वी आर प्लानिंग फॉर दैट रुपेश, ओके yes. Naru, m is 0.025 are not a large difference. Okay, so frequency of oscillation we have calculated, this is 60.4 radian per second. So in radian per second this is 60.4. In hertz what will be the answer? In hertz, if you will calculate in hertz, you will get 0.96 hertz. Okay, in hertz it will be, so we have obtained 60.4 radian per second. In hertz this will be 0.96 hertz, and this is option number B, which is correct. Okay, so all you need to do is to remember this particular important formula, guys, nothing else, isn't it? This is a very important formula. If you remember this formula, you can solve this question very easily. Okay, so Rupesh, you have seen power electronic session. Now you are in power system 2 part 2 session, and I will say that you should go to the playlist and you must watch the power system 1 session as well. Okay, because in part 1 we have discussed some fantastic questions, so you will have a great experience there as well. Okay, yeah. So after this question I have another question for you, and this, whatever is the formula required in this, is a very important formula for the GATE exam. Okay, it says a 50 Hz 3-phase synchronous generator is operating at a steady load angle of 30 degree while supplying 1 per unit of active power to an infinite bus. Its inertia constant is 8 megajoules per MVA. A 3-phase solid fault takes place which is cleared at the critical rotor angle of 85 degree. What will be the critical clearing time in seconds? So I am giving you 2 minutes. Okay, because this question belongs to a very popular formula. I think you must know that. So let me see whether you can solve this question or not. This belongs to a very popular formula. Everything is given for that formula. All the data is given to you. You have to just solve this. Okay. Let me see who can answer. Stability में 1 transmission line remove वाला question भी करा दें. 1 transmission line remove वाला question, Rupesh, right now I am not having that question. Okay. Right now I am not having that question. So before actually designing these questions, Rupesh, I have done a lot of research, and I have picked the topics from where you can get a question in the upcoming GATE exam. So if you are well prepared for that topic, you can practice that topic, and if you are not very well prepared for that topic, you can ignore that topic, because I am very sure that topic will not be there in the exam. There are 2 reasons. Because in order to solve, yes, I know that, in order to solve that particular problem where 1 line is removed or 1 line is in fault, it involves a lot of calculation, isn't it? It involves a lot of calculation, and that is why this particular case has never been asked in the GATE exam, or it will not be asked in the GATE exam, because that much calculation requires a lot of time. Okay, so you can ignore that topic if you haven't done. You can focus on these topics. But I will discuss that particular case, Rupesh, I will discuss that particular case during the revision series. Okay, so you don't have to worry. I will discuss that particular case in the revision series. Right now I am not having any question related to that particular topic, but I will discuss that topic in the revision series. So you will be aware of that topic as well. Okay, 5.6 second is the answer that I am getting. Let me see whether this is correct or not. What you have to find is the critical clearing angle, guys. Okay, critical clearing angle, that is TCR. What is the required formula for that? the required formula for it is 2 into H. 2 into H del CR means critical clearing angle minus del naught divided by pi F PM. Pi into F into PM. So have you used this formula? Have you used this formula? Tell me. From here, if you see, what is the value of del CR minus del naught? So the del CR minus del naught will be 85 minus 30. So that will be 55 degrees. And I know where you have mistaken. You have to convert this into radians. So in radians, it will be 1.91 radian. Okay. In radians, it will be 1.91 radian. Now put the values here. Now put the values here. 2 into what is H? What is H here? The value of H is how much? 8 here. Okay. The value of H is 8 and this value in radian is 1.91 divided by pi is 3.14 into F is 50 into PM is 1. Okay. Now once you will solve it, you will get 0.442 seconds. So that will be the answer. Okay. 5.6 is a very long time. Now if you are removing the fault in these many seconds, it will destroy the whole power system. You have to remove that particular fault within these number of seconds. Within second, I have to say. I have taken in degree. This is a common mistake. Okay. This is a common mistake that the students commit. And this is the purpose of GATE Score Booster series. So it is really helping its purpose and I am very happy to see that. I am very happy to see that. Okay guys. So this is a very important formula and you must remember this formula. You must remember this formula. Okay. Yes. Now moving towards the next problem. Now see this problem. Let me read the problem for you first. A machine shown in the figure has an inertia constant of 6 megawatt seconds per MVA. It is supplying 0.8 per unit of active power at 0.8 power factor lagging to the infinite bus of 1 angle 0 per unit voltage. All the per unit reactants are marked on the machine rating as base. The value of critical clearing angle in radians in case a solid three-phase fault takes place at the generator terminal will be what? That is what we have to calculate here. Let me help you and I am writing the formula for critical clearing angle del CR. The formula for critical clearing angle del CR is cos inverse pi minus 2 del naught into sin del naught, not cos del naught. Cos del naught will come later. Okay. Cos del naught sin del naught minus cos del naught. That is the required formula. And now I am giving you 2 minutes. And let me see, can you solve this question? So this is the required formula that we have. Now you have to solve this question, okay? And let me see who can solve this correctly. This is a very, very important formula. This particular formula and the last one that we have for critical clearing time, these are the two very important formula from this particular topic. Is there any tip to memorize critically clearing formula, sir? Naru has calculated the answer as well. Is there any trick the trick is, the first trick that you can remember is, the only angle used here is del naught, nothing else. Only del naught is used here, okay? Only del naught is used here, and first there will be cos inverse, okay? And it is starting from cos and ending from cos. So that is how you can memorize it, okay? That is how you can memorize it. So Rupesh is getting 112, Naru is getting 114, okay? Let me see which answer is correct. So guys, from where you have obtained the value of del naught, can you just tell me how you have obtained the value of del naught? How you have obtained the value of del naught? So for that, what has been given to us is, see, the load side power is 0.8 per unit and the power factor is 0.8 power factor lagging, and the infinite bus voltage is 1 per unit. So if we simply apply the formula, P equals to VI cos phi. So from here, what will be the I? That will be P upon V cos phi. So P is 0.8, V is 1 and cos phi is 0.8. So you will get the value of I to be equal to 1, and since the power factor is 0.8 lagging, so the angle will be minus 36.86 degree. So that will be the value of I, isn't it? That will be the value of I. Now tell me, if we want to find out what will be the value of EF angle del, then this will be equals to V plus I into J X equivalent. Yes or no? So V is what? V is 1 per unit. I is what? I is 1 angle minus 36.86. Now what will be the value of X equivalent? See, what will be the X equivalent here? So if we want to calculate the X equivalent, that will be the XD value, that is J.15, okay? Then we have the transformer whose reactance is J.2. Then we have this transmission line whose reactance is 0.5. So how much it is? 0.85, J.85 per unit. That will be the value of X equivalent that we have, okay? So let me just put the values here. So this is what is X equivalent here? X equivalent is J.85, or we may write it 0.85 angle 90 degree. So 0.85 angle 90 degree we'll put here. Now we have to solve it for EF. So once you will solve it, you will get 1.65. I have done the calculations. 1.65, 24.24. 24.24 per unit. That will be the value of EF angle del. From here, you will get two things. First, the value of EF, which is 1.65 per unit, and this is also the value of del naught here. Okay guys, this is also the value of del naught here. Okay, this is the value of del naught here, steady state angle. Okay, this will be the value of steady state angle before actually the fault has taken place. Now what I have to do, just put the values in the formula. So this is what? This is 24.24, not in per unit, this is in angles, degrees, na? This will be in the degrees. So in degrees it is this much. How much it will be in radians? 0.424. It will be 0.424 in radians. Now calculate the value of pi minus 2 del naught, because it is required. So it will be pi minus 2 del naught. Pi minus 2 del naught will be what? Pi minus 2 del naught will be 2.71 radian. 2.71 radian. Now just use the formula once again. Del CR, critical angle, is starting from cos pi minus 2 del naught into sin del naught and ending in cos as well. This is how you can remember it. Okay, this is how you can remember. Who has asked? Sai Kishore, this is how you can remember this formula. So this will be cos inverse pi minus 2 del naught you have calculated is 2.71, okay, into sine of del naught. Here you will put the value is in angle 24.24 minus cos, again you will put the value in angle 24.24. So from here I am getting the value of del CR is 88.34 degrees, or in radian it will be 1.54 radian. So this is the answer that I am getting. Why you guys are getting a different answer? Which value you have obtained which is different from my values? Tell me guys. Where you have mistaken, or is there any mistake in my answer? Just give me a reply. I am getting an answer 88.34 degrees here. You people are getting over 100. So just check your answer again, okay? Just check your answer again, guys. So this is how we can solve this problem. First of all, tell me from where you have get the value of del naught. Did you obtain the value of del naught in the same manner? The steady state angle. The steady state angle will be the angle of E, isn't it? Sir, in this problem there is polar and rectangular calculation. How can we calculate in gate calculator? Not converted in radians. So Rupesh has not converted in radians. That is why he is getting a different answer. Naru, you can practice that. Okay, you can practice that. There are a lot of things that you can search on internet how to use the gate calculator, and from there you can get how can you do these calculations. Okay, just mind these facts, guys. The radians and the degree. Okay, when sine and cos, when del naught is written with sine or cos, then you have to put the values in degrees. Here what is written? Pi minus del naught. So why will you put the values in degrees? Why will you put the values in degrees? The degree value will only be put when sine and cos are there. So with pi minus 2 del naught, there is no sine and cos. So we have to put in radian. So this is how you can remember these things, and you will never make a mistake. Okay. So this was the last problem from the topic power system stability. So I am expecting these questions to be there in the gate exam from this topic. Okay guys, so just practice these questions as many times as you can. Just practice these tricks and just practice these concepts as many times as you can, because fault analysis and power system stability are two such important topics. Definitely they will give you a question in the gate exam. Okay, now moving towards the next topic, which is power system protection, the very ignorant topic, the very ignored topic. Okay, in power system generally we used to just study so many topics, but we used to just ignore this topic. Okay, so I have chosen few very important questions that you can expect in the upcoming gate exam. So just be with me and see what questions I have for you from this particular topic. So the important topics are relays and circuit breakers. Now let me be with the very first question. So this is the question that I have for you from this topic. Let me just read this question. In a 220 kV system, the phase to ground capacitance is 0.01 microfarad and the inductance is 4 Henry. If a magnetizing current of 4 ampere is interrupted, then option A says the voltage appearing across the electrode of circuit breaker is 80 kV. The value of critical, option B is the value of critical resistance to be connected to eliminate the restrike is 0.05 mega ohm, and option C and D says that the voltage is 100 kV and the resistance is 10 kV. So what is the correct answer and what is the required formula to solve this question? I am leaving it up to you, and I am giving you only 1 minute, because 1 minute I think is sufficient. I think 1 minute is sufficient to solve this question. Okay. And this is the general case in circuit breaker. If you know the formula, you can solve the problem. If you don't know the formula, you will not be able to solve the question. And very few formulas are there to remember in circuit breaker. So Rupesh, since this is a gate score booster series, so I have to be very limited with some important questions. So here I can't discuss each and every formula and each question related to each and every formula. But if you want that kind of thing, we are just coming with the revision series. So soon you will get an announcement for that. and there we can discuss all the concepts, all the formulas, and in very less time, within 3 hours, within 3 to 4 hours, we will revise the complete subject. So be there for that announcement, okay? And soon we will do the same kind of things. So the time is up. I think you don't have the required formula, because if you had the formula, you can solve the problem very easily. So the guys, the voltage appearing across the electrodes, that is given by V equals to I under root L by C, and the resistance that need to be connected is R equals to 1 by 2 under root L by C. These are the required formulas, okay? The voltage appearing, this is equals to V equals to I under root L by C, and the resistance to be connected is 1 by 2 under root L by C. Now can you give me the answer? By using these formula, can you tell me which are the correct answer? So if you'll put the values, what will be the value of voltage and what will be the value of resistance? Can you tell me what answers you are getting right now after putting these values? Can you just tell me which option is correct or which options are correct here? This is an MSQ type of question, so more than one options are correct. Just solve these and tell me now what answers you are getting here. So just after putting the values, guys, you will get the voltage value to be 80 kV and the resistance value will be 10 kilo ohm. Okay, so that will be the answer. So looking into these options, options A and D will be the correct option. Yes, very good, Naru. I am also getting option A. So option A and D will be the correct answers. Okay. So I hope you are done with this problem. Let me move towards the next problem. Now see this problem. This is a very interesting and very good problem. Okay. Let me read this problem first of all. The figure shows a percentage differential relay used for the protection of an alternator winding. The relay has a minimum pickup current of 0.2 ampere. It is a what we can say, it is the preset value, isn't it? It has a minimum pickup current of 0.2 ampere. So whatever formula pata nahi tha, no problem. No problem, I have written the formula. So you can see that formula. So this is the preset value that we have. Whatever value we have we are going to calculate, we have to add this value in the answer, okay? And has a slope of 14% if a high ground resistance fault occurs near the grounded neutral end of the generator winding with the current distribution as shown in the figure, then what will be the operating current? What will be the operating current? That is what we have to calculate. So I am giving you 1 minute only. Okay, it does not require more than 1 minute. It is as simple as that. And you know the required formula for this. Slope is given, guys. Let me give you a hint. The slope is I1 minus I2 divided by I1 plus I2 by 2. This is what? This is the current in restraining coil, and this is the current in operating coil, and this is what you have to calculate. Okay, this is what you have to calculate. So this is the required formula. Now let me see, can you solve this question? So what I have told you, that the slope is given to us. Okay, the slope is given to us, and what is the slope? Slope we calculate by I1 minus I2 upon I1 plus I2 by 2. Okay, this is the current of restraining coil. Okay, this is the current that restraining coil carries, and this is the current that operating coil carries, and this is what we have to find out. Okay, this is the operating coil current. Operating coil in differential relay carries I1 minus I2 current, and restraining coil carries I1 plus I2 by 2 current. Okay, so what we have to find out is what is I1 minus I2, and the slope is given to us. The slope is 14%, that is 0.14. So I'll come back to this equation once again. Before that, how do we find I1 plus I2? So guys, if you see, this is the value of I1 that you have, and this is the value of I2 that you have. Okay, so let me calculate I1 plus I2 by 2. So I1 plus I2 by 2 will be what? 350 plus 310 divided by 2. How much this will be? 660 by 2, that is 330 amperes. Okay, now 46.2, 46.2, no, this is not the correct answer, Naru. I know what mistake you have done here. Okay, let me be very clear. This I1 and I2 we have calculated on CT's primary side. Okay, where do you connect the relays? The relay that you will connect will be on this side, na? The relays will be on this side, yes or no? The relays will be on the secondary side. Here is your operating coil. This is your operating coil. So this I1 plus I2 by 2 that you have calculated is on the primary side of the circuit breaker, isn't it? When it comes to the secondary side, what will be the I1 plus I2 by 2? Okay, I am writing this with a small letter so that you will get the fact that it is on the secondary side. So primary side you have this average. What will be the average at secondary side? For that you have to divide it by 5 by 500, which is actually the ratio, sir, CT ratio here. So that will come out to be 3.3 ampere. Yes or no? Now did you get the fact? That will be 3.35 ampere. Did you get the fact? Let me tell this once again to you. Let me just rub this up. Let me make a restraining operating coil, restraining coil or differential relay for you, and then you will get the fact. Okay, see guys, what do we have here? See, this is how we will connect, this is how we will connect the operating coil. Okay, if this is current I1, here it is the current I1, and here it is the current I2 here. Okay, so how much current is there? Current is I1 minus I2 here. Okay, and we can also make the restraining coils. Here we can make this restraining coil, here we can make this restraining coil. So here the current is I1 by 2, and you know that here is the current I2 by 2. Okay, this is the restraining coil that we have, this is the operating coil that we have. Okay, so whatever I1 plus I2 by 2 we have calculated, that is for what? That is for the primary side of the CT. Relay is connected on the secondary side of CT. So this average will be what on the secondary side? You have to convert this average into the secondary side by multiplying it with this CT ratio. So this is what we get at the secondary side, isn't it? Now, what is given to you? Slope. Now, what is slope? Slope is basically I1 minus I2 divided by I1 plus I2 by 2, and this is what? This is 0.14 given to us. Now, what we have to find from here is that what will be the operating coil current. Now, operating coil carries how much current? I1 minus I2. So this will be what? This will be 0.414 times the I1 plus I2 by 2. But guys, do not forget to add this factor because this is a preset value. Okay, by default we have 0.2 value here. So do not forget to add 0.2. Then how much you will get? 0.14 into 3.3 plus 0.2. How much this will be? This is 0.66 amperes. This is 0.66 amperes. So, Naru, did you get the fact where you have actually mistaken this problem? Tell me, did you get the fact where you have actually mistaken this problem? Tell me whether you have got the fact, where you have actually mistaken. Have you calculated I1 minus I2 by subtracting 350 minus 310? In that case, how much you will get? You will get 40. Okay. Yes. So don't do that thing. Okay. Just remember the fact these coils are connected on the secondary side of the CT, na? Not in the primary side. And primary currents are given to you. And last but not the least, do not forget to take this 0.2 value. What is the purpose of this 0.2? This is a kind of preset value. Okay, if nothing is happening, 0.2 ampere current is already there in the operating coil. If something is happening, then 0.2 will be added to the next coming current, isn't it? So that is what we have done here. Okay, so that is the purpose of choosing this problem. I hope this problem will teach you a lot of things. Okay, and you can expect this problem, this kind of problem from differential relay in the upcoming exam. Okay, very good, yeah, very good. Now moving towards the next problem. This is a fantastic problem that I have. The time of operation of a 5 ampere 3-second overcurrent relay having a current setting of 125% and time setting multiplier of 0.6 connected to supply current through a 400 by 5 current transformer will be what? So we have to find out the time of operation of relay. Okay, the time of operation of relay, this curve is given, and that is what we have to calculate. Okay, that is what we have to calculate. So in the curve, if you see, for a corresponding PSM, we have the operating time. So this gives you an impression that we have to find out the PSM, and whatever PSM we are finding in the curve, we have to look for that corresponding PSM. What will be the operating time, isn't it? That is what you have to do. So this much hint is enough to solve this problem. Now let me give you a timer, and I am giving you 2 minutes. Let me see whether you can solve with this hint. You have to find PSM and then you will get the operating time from the curve. Actually, sir, I cannot visualize the circuit diagram. No problem. But Naru, now you are able to visualize, na? Now you are able to visualize. If you are able to visualize the things right now, the purpose is solved. Very good. Very good, yeah, very good. Now focus on this problem because the time is running up. Okay, so this curve is giving you a hint. We have to find out the time of operation, and this curve is giving you a hint that we have to find out the PSM. Then we will be able to find out what will be the operating time looking into the graph. Okay, so let me see whether you are able to solve this question or not. This is a very good question. %90 of the students will go through all difficult topics of power system, and 90% of them will definitely ignore this particular topic, power system protection. Okay, but guys, this is a kind of topic from where a very silly questions will be asked in the exam, and you will be able to solve within seconds that question. Okay, so I have selected those questions that you can expect in the upcoming exam. Okay, so practice these questions from this topic. Do not ignore this topic. Okay, so last 5 seconds we have, and I'm not getting any answer. So what am I telling you is that you have to find out the PSM. Now what is the formula of PSM? The plug setting multiplier. Okay, plug setting multiplier, that is PSM. What is the formula of PSM? This is equals to fault current. This is equals to fault current divided by the current setting. CS means current setting into CT ratio into CT secondary current. Okay, so this is the formula of calculation of PSM. Now, what is the fault current given to us? The fault current given to us is 4000 ampere. So 4000 ampere is the fault current. Current setting is how much? 125%, that is 1.25. CT ratio is 400 upon 5 and the rated CT secondary current is 5 ampere. Okay, so from here how much you will get? From here how much you will get? You will get the PSM value to be 8. Now can you tell me, if the PSM is 8, how much PSM we have obtained? The PSM value that we have obtained is 8. Now can you tell me, for PSM value of 8, what will be the operating time? Tell me guys, for the PSM value of 8, what will be the operating time? Can you tell me? Looking into the graph, can you just tell me, for the PSM value of 8, what will be the operating time? 3.5, isn't it? And that is where you have mistaken, my friend, because for PSM 8, the operating time is 3.5. But why are you forgetting this particular thing? The time setting multiplier is 0.6. Okay, so for the PSM 0.8, the time that you have is 3.5 seconds. But actual operating time will be what? Actual operating time, that will be 3.5, and we have time setting multiplier as well. So whatever PSM is giving you the time, you will multiply it with the time setting multiplier. Finally, then you will get the actual time required. So you can see 3.5 is also there in the formula, in the options. Okay, yes, 3.5 is also there in the option. So we have option B correct. Okay, now 99% students will do the general mistake for PSM 8 3.5. Okay, they will generally choose it. But why are you forgetting time setting multiplier? If there is no time setting multiplier, 0.35 is the answer. Okay, 3.5 is the answer. 3.5 is the answer when there is no time setting multiplier. But when we have time setting multiplier, in that case you have to multiply 3.5 with 0.6 second. So 2.1 second will be the correct answer. Is that clear right now? Tell me guys, is that clear? Is that clear? Will you remember this important fact? Very good. So moving towards the last topic of power system, that is performance parameters of line. And the important topics are inductance, capacitance of transmission line, GMD, GMR, classification of transmission line. Now guys, from last couple of years, we are getting regularly problems from GMD, GMR, inductance and capacitance. This year, my guess is that now you are going to get a problem from this particular topic, classification of transmission line. This is a very hot topic. This is a very important topic that will definitely give you a problem in this particular exam. Okay, in this particular year. So what problems I have for you from this case, let me just show you. So although this is a previous year problem, but still I just want to discuss this with you because this is very important, and this type of case will be repeated in the GATE exam. Okay, so what it says is, for a 400 kilometer long transmission line, the series impedance is 0.0 plus 0.5 ohm per kilometer, and the shunt admittance is 0.0 plus j5.0 micro ohm per kilometer. What will be the magnitude of series impedance in ohm of the equivalent pi circuit of the transmission line? Okay, so the line length is 400 kilometer for operating frequency of 50 Hz. This is a long transmission line. So if you are how to calculate GMD, GMR in bundle conductor, Rupesh, for that you have to wait. When we will be there in the revision series, there I will elaborate how to calculate GMD and GMR. Okay, the purpose of GATE score booster series is to make you aware of the important questions and concept which will help you to score more in the upcoming GATE exam. Okay, so in order to solve that purpose, I have to be very selective while choosing the questions of GATE Score Booster series. Okay, and my personal guess is that this year there will be not any question from GMD and GMR. There will be a question from this particular topic, classification of transmission line. But if you want to know what is GMD and GMR, you have to wait for that. Okay, in the upcoming revision series I will cover those topics. And if you really want to go through how to calculate GMD and GMR, go to the playlist. The last year when we had revision session, there I have discussed how to calculate GMD, GMR and everything I have discussed. So you can go for that. You can just visit that particular video from our playlist. Okay, yeah, just focus on this problem first of all. So 400-kilometer long transmission line is there. It is a long transmission line. So when we are representing a long transmission line into its pi equivalent, what will be the required value? So if a long transmission line is represented in its equivalent pi network, what are the different values of series impedance and shunt admittance we have? So this is the series impedance that we have, and it has a value ZC equals to, this is the series impedance that we have Z, and Z is equals to ZC sine hyperbolic gamma L. Okay, this is Z, and Z is equals to ZC sine hyperbolic gamma L. Okay, and this is the shunt admittance that we have Y by 2, and it is equals to what? This is equals to tan hyperbolic gamma L by 2 divided by ZC. So this is the equivalent pi network of a long transmission line. Okay, this is the equivalent pi network of a long transmission line. Now what we have to calculate here is the magnitude of the series impedance. We have to calculate the value of Z here. So Z we can calculate by ZC sine hyperbolic gamma L. Okay, now you can see for that we require what will be the value of ZC and what will be the value of gamma L, isn't it? So guys, what is the value of Z here? Z is given to be J.5 ohm per kilometer. So in ohms it will be, we have to multiply it with by 400, the length of the line, and you will get the value of Z. This is equals to J 200 ohms. Similarly, what will be the value of Y? The value of Y is given J 5.0, isn't it? J 5.0, but it is in micromho. So 10 to the power minus 6 into 400 is what we have to do here, and what we will get the value of Y here is, it will be equals to J 2 into 10 to the power minus 3 mho. Okay, that is the value of Y. Now you can calculate the value of ZC, which is equals to under root of Z upon Y. So just put the values here. What is Z? Z is basically 2 into 10 to the power minus, sorry, Z is basically equals to 200 here, isn't it? Z is 200, and the value of Y is 2 into 10 to the power minus 3. So when you will solve it, you will get 316.2. that will be the value of ZC. So this is how we can calculate. सर क्या इससे याद रखना पड़ेगा? किसको याद रखना पड़ेगा? इसको याद रखना पड़ेगा. This is a very simple thing यार, you can remember this, isn't it? And this is the fact they want you to remember यार. थोड़ा बहुत तो याद रखना ही पड़ेगा ना. You are appearing in the GATE exam. Okay, how you can remember this? Practice makes a man perfect, guys. So practice these things as much as you can. By practicing, this will be there stored in your memory. So you need not to remember a lot of things. Okay, if you have seen my power electronics video, I have shown you how you can derive a particular formula from the scratch. Okay, so by practice you can also remember these formula. Yeah, there is no problem. Okay, now so ZC we have calculated. Okay, now after ZC we require to calculate the value of gamma L. So how do we calculate the value of gamma L? Just see guys, gamma is what? Gamma is under root Y into Z. Okay, under root Y into Z. So just put the values of Y and Z, and see, you are calculating gamma L here. Okay, what is the value of y here? Y is 2 into 10 to the power minus 3. What is the value of Z? 200 here. So what will be the value of gamma L, guys? Gamma L will be having a value 0.632, and this is in radian. Again, this radian concept and degree concept, and where you have to divide by root 3 and where you have to multiply by root 3. This will snatch 5 to 6 marks from you. So be very cautious with these facts, guys. Okay, so whatever you will calculate, that is coming in radian, so you have to convert this into degree. So we have calculated now the value of gamma L, and we have calculated the value of ZC. Now it's time to put the values here. So just put the values here. What is ZC? 316.2. Sine hyperbolic gamma L is 0.632, but it is in what? It is in radian. Okay, it is in radian. It is in radian, guys. So you have to convert it into degree. So multiply with 180 upon pi. Okay, multiply with 180 upon pi. What is Z? Z required here is ZC sine hyperbolic gamma L. So what is ZC? 316.2 sine hyperbolic. What is gamma L? We have calculated it 0.632 in radians. So multiply by 180 upon pi. So we will get in degree. Once you will solve it, you will get 187 ohms as the answer. Ranju Karmakar, sir, when power electronics session came? Ranju, I have already taken those session on 13th and 14th of December. You can subscribe our channel and you can just go to our playlist. Those videos are there and you can see those videos n number of times. Okay, those will be very helpful for you. So you can just go in our playlist and you can see those videos as many times as you can. Where there I have discussed very important questions. Okay, so this is how you can do this problem, guys. This is how you can do this problem. So as many times as you can practice these questions, just practice it, because this is very important. And I am expecting that this kind of questions will be there in the upcoming GATE exam. Okay. Now, moving towards the next question. I hope this is very, very clear to you. Naru, Rupesh, Ranju, this is very, very clear to you, guys. Did you get the fact how we have solved this question? I hope so. So moving towards the next question. What is there in the next question? What has been given to us is the nominal pi circuit of a transmission line is shown in the figure. So we have a nominal pi circuit of the transmission line. So in nominal pi circuit, the series branch is impedance branch and the shunt branch is the admittance branch. In the last problem also you have seen, this is the series branch and this is the shunt branch. So shunt branch is what? This is in the admittance form. Okay, so this is y by 2 is what is given to you. Now what we have here is impedance Z is equals to 100 angle 80 ohm, reactance X is equals to 100 ohm. The magnitude of A of ABCD parameters of the line will be what? So what we have to find? We have to find the value of A, guys. We have to find the value of A. So you know the ABCD parameters of pi model. ABCD parameters of pi model. So from there the value of A or D, this is equals to 1 plus yz by 2. So the value of A or the value of D is how much? This is equal to 1 plus z by 2. So all you required is to know the value of y and the value of z. Ranju has calculated 501. Whether 501 is the correct answer? No, Ranju, this is not the correct answer. Okay, so Z value we already know. What is Z? Z is given to us 100 angle 80. Now we have to calculate the value of Y value of y here. Okay, so if you see the reactance value is given to us. Okay, this is what, this is the admittance value. Okay, so y by 2 is the admittance value. Now if we want to convert this reactance into admittance, what we have to do, we have to do 1 by x here. Did you get this fact? Did you get this fact? Just give me a reply. In nominal pi model, this shunt branch represents the admittance y by 2, but what has been given to us is a reactance, isn't it? What has been given to us is a reactance. So we have to convert, if we want to equate them, this is admittance, this is reactance, so we have to inverse it, then it will be equal to the reactance. Yes or no, guys? Now from here, what we have to calculate is the value of y by 2. So the value of y by 2 will be what? Or the value of y will be what? It will be 2 by x. Yes or no? The value of y by 2, the value of y will be what? The value of y will be 2 by x. Okay, so we have 2 divided by the value of x is how much? The value of x is 100. Okay, now it's time to put the values in this particular formula. So what values of a we have? 1 plus yz by 2. So 1 plus, the y is having a value of 2 by 100 into z is having a value of what? 100 angle 80. That will be divided by 2. So what we will get? We will get 100, 2 and 2 get cancelled. We will get 1 plus 1 angle 80. Now finally when you will solve it, you will get 1.52 angle of 32.81. Okay, so what is the value of a? We have to put the magnitude of a only, so it will be 1.52. Okay, yes, now Hers has got the correct answer. Hers, you have joined very late today. So Ranju and Rupesh, did you get the fact where you have mistaken here? How 1.5 is coming to be the right answer here? Okay, and just remember the fact, in pi model, the value of a and d, even if you represent the line in t model as well, even then the value of a and d is equals to 1 plus yz by 2. Okay, so just remember the fact. If you are able to remember the fact, I am sure you can solve this problem. So this year I am expecting a question from classification of transmission line in the upcoming GATE exam, and for that this particular question and this particular question will be very useful for you. Okay, so classification of transmission line will definitely give you a question in the upcoming GATE exam. Not convert x in admittance, that is the common mistake that you will do. Okay, and that is the Rupesh. Now you are getting the fact. This is the purpose of GATE Score Booster series, to make you aware of the facts, to make you aware of the important concept and question, and to make you aware where you can actually mistake, where you can commit mistakes. Okay, so by joining this session and doing this question as many times as you can avoid doing mistake in the actual exam. Why x is written 1 by x? See, in equivalent pi model, series branch represents the impedance. Okay, but the shunt branch represents the admittance with a value y by 2. Okay, so y by 2 means admittance has to be there, but what is actually there? It is x, and what is x? X is reactance. So reactance is the part of impedance. How will you get admittance from impedance? 1 by impedance is actually the admittance. Okay, so x is reactance. You know na, z is equals to r plus jx. This is resistance, this is reactance. Okay, in the admittance form, this is what? This is equals to g plus jx. This is conductance, and this is what? Susceptance. Okay, so when you will get y, when you will inverse z, then you will get y na. So that is why सर अगर x की जगह z रहता तो भी कन्वर्ट करते. आपको x और z में फर्क क्या है? x is the reactance, z is the impedance. Reactance is the part of impedance. You see, reactance, this is reactance, reactance is the part of impedance. So whether x reactance is there, whether resistance is there, or complete impedance is there, you have to inverse it in order to get the admittance, because pi model has admittance. So now, are you getting, Rupesh? Did you get this particular fact? So guys, this is the end of this GATE Score Booster series of Power System Part 2. I hope you people have enjoyed this series a lot because we have discussed some very important questions. Now part 1 and part 2 of Power System and Power Electronics, just go and see from the playlist as many times as you can, because I have put a lot of effort into it to make you aware of the concepts and the tricks and the things that you can expect in the upcoming GATE exam. Thank you, sir, for helping in revision by important formulas questions. Very good. Okay, so I think this is the end of the power system right now. So just go in the playlist and see the videos of power electronics, power system as many times as you can, because the total weightage of power electronics and power system in the GATE exam is 25 marks, guys. 25 marks are more than enough. If you are able to score all those 25 marks, guys, you can be a topper, isn't it? By very simply you can qualify the GATE exam and you can be a topper, isn't it? 25 marks are more than enough. सर क्वेश्चन में कहा है कि एक्स रिएक्टेंस है, अगर क्वेश्चन में नहीं लिखा हुआ होता तो क्या होता? भाई बताना तो पड़ेगा ना क्या है, बिना बताए कैसे करोगे? उसको बोलना पड़ेगा कि एक्स रिएक्टेंस है. ओके, ऐसे नहीं चलेगा रुपेश, उसको बोलना पड़ेगा कि एक्स क्या है. रंजू इज सेइंग थैंक यू सर फॉर गिविंग ब्यूटीफुल क्वेश्चंस. ओके, थैंक यू रंजू. सो गाइस, now let me tell you about, now you have seen how beautiful questions I have designed. If you want to experience such an experience, if so, for that you have to be with us. So let me just reveal you the fact what we are offering here at IMS GATE Academy and why you should join us. Okay, so let me reveal you about the features of IMS GATE Academy. So in IMS GATE Academy, we are having classroom program, fully offline program. We are having hybrid classroom program, online plus offline, both mode will be offered to you. Exclusively live online program, completely live program. Okay, अगर x admittance होता तो convert नहीं करते, नहीं तब नहीं करते, then y by 2 equal to x होता. ठीक है, then y by 2 which is admittance equal to x होता अगर x admittance होता, तब नहीं करते ऐसा. Okay रुपेश, since x is in shunt, if there is not written then we can assume it is admittance. नहीं, ऐसा नहीं करना है नयन, x के बारे में उसे बताना पड़ेगा यहाँ पर वो क्या है. ठीक है, y by 2 एडमिटेंस होता है ये हमें पता है, बट शंट ब्रांच जो दी है वो एडमिटेंस फॉर्म में दी है कि इंपिडेंस फॉर्म में दी है, दैट द एग्जामिनर हैज टू टेल यू. ओके, जस्ट डोंट प्री-अज्यूम थिंग्स. आर यू गेटिंग नयन? From our side we have y by 2, that is a fact that this is admittance. Now the shunt branch is represented by an admittance or reactance or impedance that he has to tell you, and if you see in the problem he has already told you. Okay, yes, exclusively live online program. Here we are offering you completely live program, guys. So I know that it's very difficult to, yes, in the revision series I will definitely take a question like that. Okay, so Rupesh, what am I seeing, and then what am I seeing, that GATE Score Booster series is helping you quite a lot, and it's actually serving its purpose because you people are raising question in that particular question. So I think that concept has really stuck you at some point of time. So if you cleared this particular concept, you will not going to make a mistake in the GATE exam. Okay, so definitely this will be there will be a question from this topic, and I'm very sure you are going to score more than what I am expecting from you. Okay, now live online program, guys, it is very difficult to manage time nowadays. So for that we have designed this live online program where we are giving you complete content delivery in online manner. So it will be a live 3-hour class per day. So it's very easy to maintain that 3 hours. So that is why this live online program is very well designed here at IMS GATE Academy. Then we have self-learning program. If you can't manage your time offline, online manner, then we are giving you self-learning program as well, where we will give you 450 hours of live recorded content, so you can just go through the content in self-study manner. Okay, so this is a self-learning kit that we are offering here. Now we have courses for mechanical, civil, electronics engineering, electrical engineering, and instrumentation or computer science engineering. Our program features include 750 hours of live classroom session. Okay, in online, offline, and hybrid, we are offering 750 hours of live classroom program. Apart from that, you will get 20 to 30 books, theory books and exercise book, which contains 4,000 practice questions. Okay, that number of questions are very well designed by us. So you have seen the quality of question that we have discussed in GATE Score Booster series. So even beyond that expectations, okay, that expectation, very good questions we have designed in our exercise book. So if you are going to practice these number of questions in exercise book, nobody can stop you to be a topper in the GATE exam. Okay, GATE question books we are providing, and doubt solving portal we also have. Let me tell you about doubt solving portal also as well. Apart from that, we will give you my plan session, 130 plus test series. Okay, full length GATE test, GATE score booster series that you are now enjoying, post GATE interview. After GATE, what you should do, we will also advise you. Now we believe in learn, practice and test, LPT methodology. So we will make you learn all the concepts in our live online or offline classes. Then for practice, we are giving you exercise book that have more than 4,000 plus practice questions subject wise. And then we are offering you 130 plus test as well to test yourself. So if you are learning, practicing and testing yourself in a positive manner, you are actually on a right platform. Now our test series contains 84 plus chapter test, 12 subject test basic level, 12 subject test advanced level, 8 multi-subject test and 12 full length mock test. About study material, so we are offering 24 theory and exercise book for mechanical engineering students, 30 theory and exercise book for civil engineering student. For EC this number is 22, for electrical this number is 24, for IN this number is 26, and for CS this number is 26. So exercise book and theory book, these we people have designed in a very sophisticated manner, so this is going to help you a lot in all manners. So this is the look of our student portal. So there you can see we have a dedicated portal for doubt section, performance. You can track your performance, you can enjoy our courses. Now dedicated doubt portal that we have, there you can post all your questions. So while you are learning or practicing anything, आप कौन सा सब्जेक्ट डील करते हैं? I deal with power electronics, power system, signal and system and EMFT. Nayan is saying this booster series are very helpful, but sir, forgetting formula and also spoil many formula. For that you have to practice and practice, Nayan. Okay, so we have a dedicated doubt portal. So if you are learning or practicing something and you are getting any doubt, then you can immediately post your doubts on the doubt solving portal that we have, and we will solve all your doubt within 24 hours. Okay, now after that we have my plan session. Now if you are learning, practicing and testing yourself, even then you are getting problem in some topics, you are getting problem related to preparation, then guys, for that we have one-to-one mentoring session where you can engage with us in one-to-one manner, or we have one-to-many session where we can engage so many students with us in one time. So how these are going to help you? There you can discuss all your problems related to what will be the preparation strategy that you should follow, what should be the revision strategy that you should follow. In many way you can see any session came sir upcoming days. Yeah, now we are planning revision sessions, so very soon we will announce that. So just subscribe our channel so that you get the notification, and there you can see what is the upcoming plan with which we are coming right now. Okay, very soon, Rupesh, very soon it will come. Okay, very soon it will come. So if you have doubts regarding preparation strategies, revision strategies, that you can discuss with this one-to-one or one-to-many my plan session. This is a very good initiative that we people are offering you. After that, if you really want to test us, you can just visit our site www.imsindia.com and you can go to this GATE ME section and you can see there is a zero fee program. So you can join us without paying any fees, guys. And there we are offering you 100 plus hours of concept video, 12 chapter test, 6 subject test, 6 pass gate papers. So you can enjoy all these features at free of cost, and you can just check what we people are offering. So before actually joining, you can check those things. This is free of cost. This is zero fee program that we are offering. Nobody else is giving you. So you can join us without paying anything, and you can just check us what quality of content we are giving, and then you can make your move to join us. Okay, then you can make your move to join us. Okay, guys. Now, very important announcement. We have new batch announcement, and this is a very important information for you guys. So see, live online batch. So in live online batch, guys, we are at 3 January, at 3 of January and at 7 January, we are starting our new batches for EC electrical ions, signal and system will be there. We are starting with signal and system, and from weekend we are starting with networks for mechanical and civil, engineering mechanics, FM and hydraulics, and for CS, TOC and operating system will be there. So you can just note down this number. If you really want to join us, you can join us. Okay. Now after that, classroom new batches, offline batches. So our offline batches are starting from Sunday 8th of January. For EC electrical and we are starting with digital, for CS as well. For mechanical and civil, we are starting with SOM. This is the address and this is the number. You can just note it down. You can make a call or a message if you really want to join us. Now hybrid classroom program, where क्या offline class भी होता है? Yes, Rupesh, absolutely. The hybrid program is a program where we are offering you 2/3 of offline plus 1/3 of online program. Okay. So hybrid complete offline program is also there, but it is there in some respective centers like Ahmedabad, like Bangalore, like Vijayawada. These are the centers we are offering, where we are offering fully offline classes as well. Okay. If you do not belong to these center, you can join us in online manner as well. So in hybrid classroom program, which is starting at Vijayawada center, we are starting our hybrid classroom program. Hybrid means online plus offline, 2/3 offline plus 1/3 online. So there the batches are starting also from 3rd and 8th, and signal and system and control systems are starting there. For mechanical and civil, engineering mechanics and FM and hydraulics are starting there. Okay. So these are the contact number. You can note it down if you belong to that center, or if you are there. Yes, Rupesh, bilingual language. Yes, of course, Rupesh. Language is not a problem here. Okay. So this is the end of this particular session. I hope that these sessions are going to be very, very useful for you. You guys have enjoyed these sessions a lot, and these sessions are going to help you out in all the manners you actually wanted to be. So this is the end of this session. Thank you so much for being there and for solving all the questions and giving answer, guys. So best of luck for the upcoming GATE exam. Thank you.